Hi, pre-calculus. Okay, I went ahead and I've gotten the answers here. I haven't double checked everything, but we're going to walk through some of them and make sure they're okay. So you can kind of snap a picture at this and check your work, but I kind of want to walk through some of them. Okay, so the first chapter, the first section on page 54, I want you to do 1, 2, and 7, and I wanted you to actually use the table to see if we can find the limit. See, if I plug in 2, I would get 0 over 0. Now, I've taught you could cancel out and plug in. What you do is you put 1.9 everywhere you see an X, and just make sure you put the top and bottom in parentheses. Then put 0.199 and then 0.19999. You're going to see that both these get closer and closer to 0.3333, which is your 1/3. For here, if you plug 1.9 in, 1.99, 1.99, if you plug all these in, and make sure you put the top and bottom in parentheses. As you come in from the left and right, you're getting closer and closer to 0.25, which is 1/4. For this one, if you plug all these numbers in here, you're getting closer and closer to 1. It'll say 0.9, 0.99, 0.999, 0.9, 0.9, 0.999. And from the left and right, I'm getting closer and closer to 1. So then when we go over here, these are using the graphs to do it. So 1 just says, hey, as I approach 3 from the left and the right, what am I getting closer to? Well, I'm getting closer to 1. So the answer is 1. For number 10, as I approach 1 from the left and right, I'm getting closer to 3 and 3. So the answer is 3. Here, even though these are piecewise functions, here's the idea. It's what's my graph is getting closer and closer to from the left and right. If I plug in 1.9, 1.99, 1.999, I'm getting closer and closer to a y value of 2. If I plug in 2.1, 2.01, 2.001, I'm getting closer and closer to a y value of 2. So the y value is 2. It's what the graph is approaching from the left and right, not where the graph is at. So make sure you get that conceptual understanding. The idea of a limit is what you're approaching from the left and right. So in this case, I'm going to end up approaching 1 from the left and the right. I'm getting closer and closer to 3, even though the actual curve is at 1. This limit's answer is 3. So when I go to number 13, as I approach 5 from the left, I'm approaching -1, but from the right, I'm approaching 1. If those two numbers are different, this limit does not exist. So this is your first type that I told you it does not exist, or the most common. The second is if you're approaching a vertical asymptote, the limit does not exist. Now, I've taught you if your limit is one-sided, we can actually say if it's going to -infinity or infinity. But a limit in general, if it's not one-sided, if it's an asymptote, you can immediately say does not exist. So as I approach pi over 2, it does not exist because it's an asymptote. 16, when I plug in 0, though, if you look, the secant of 0 is 1. This is the oscillating behavior I told you. It does not exist, okay? And then 18, if you plug in 1, it's the sine of pi, which is 0, all right? So that's what we did in the first part of the homework. Then I asked you to go to page 65. The first rule of, I taught you how to do a table, then I taught you how to do it graphically. Then I said the most easiest, though, is actually just substitution. If you sub in and get a number, that's going to be what you get. So in 5 through 22, which actually I just had you do 5 through 16, I went ahead and I put the answers on here. So plug in, see if these things are what you get. I may have made a little mistake, but, text me or email me if you got something different. We'll see what's happening. Now, if we go down here, I just want to make sure you know some functional notation. If I say find the limit as x approaches 1 of f of x, you just plug it in here in f and you get 4. What's the limit as I approach 4 in g of x? You plug 4 in here, and 4 cubed is 64. Now, when I say find the limit of g composed of f of x, remember what you do is you do f of x first. So you plug 1 into f of x, which gives you 4, and then you find g of 4, and g of 4 ends up being 64 again. Okay, so try those out if you can. When you get down here to these trig ones, this is where I wanted you to use this. So I wish I could have got you this, this little thing, but it says, hey, what's the secant of pi over 2? What's the sine of pi over 2? Well, if it falls on an axis, I told you I wanted you to go to your graph, your answer is 1. What's the tangent of pi? Well, I wanted you to go to the graph and say, hey, the tangent of pi is 0. So what's the cosine of 2 pi over 3? Well, if it doesn't fall on an axis, this is where I want you to use your unit circle. 2 pi over 3 here, and if you remember, the cosine is the first thing in parentheses, so your answer is -1/2. Okay? So I put those on there. I think I even had you do those, but if not, I just kind of went over them. Okay, up here, sorry, the lights in my closet are bad, but I just some notation-wise, if I say the limit of f of x is 2 and the limit of g is 3, they're going to ask you to do some stuff. If they ever say 5 times a function, you just take 5 times the limit. So 5 times 3 is going to give you 15. If they want you to add the limits together, you just take 1 plus the other, so you'd get 2 plus 3, which is 5. If they ask you to multiply them, you multiply them to get 2 times 3 is 6, and divide, you'd get 2 over 3. So once again, I kind of gave you the answers on what those things would be. Okay, so I gave you a bunch of answers of what's going on. And then finally, on 49 in this section, these are the ones that I said to you, okay, I want you to sub 5 in first in 49. You get 0 over 0. That alerts you that you can go ahead and simplify it. So factor the bottom into x minus 5x plus 5, cancel out the x minus 5s, and your new function is 1 over x plus 5, then plug it in and you get 1/10. Okay, try some of those, but I went ahead and I gave you the answers over here. When you get to 53, I know it's a little bit trickier, but just multiply the top and bottom by the conjugate of this. So it's going to be root x plus 5 plus root 5 is what you're going to multiply. And on top, you're going to see that it's going to simplify to just be x. So the top is going to cancel out with the product of those two, and you're just going to get 1 over the square root of x plus 5 plus root 5. And then you just plug it in from there. You can try the same thing here and here. Then I asked you to go to page 76, and these were one-sided limits. So I gave you the answers here, but then all you need to realize is in a smooth continuous function, the limit from the right is 1, the limit from the left is 1, so the limit is 1. So A, B, and C are all 1. Same thing here, the limit is -2. I'm getting closer to -2, therefore my limit's -2. Here's where I need you to make sure you have the conceptual understanding. As I approach 3 from the right, I'm getting closer and closer to 0. As I approach it from the left, I'm getting closer and 0 to 0. So A and B are 0, that means C is 0. Even though my curve is at 1, a y value of 1, this limit is actually 0 because it's what's happening around that x value, not at it. Same thing here. I'm getting closer and closer to 2, so each of these things are 2. Now, here's going to be 2 instances to where the limit does not exist. As I approach it from the left, I'm getting closer, or from the right, sorry, I'm getting closer to 2. But as I approach it from the left, it's -2. So therefore, if these two aren't the same, this limit does not exist, which I kind of put it in the answers over here for you. Same thing here. As I approach it from the right, it's 0. From the left, it's 2. So since they're the opposite, or they're not the same number, we can go ahead and say the third, the limit does not exist. So I put that one right there. Okay, these things are asymptotes. I need you to graph them and tell me if you're going up or down. So for instance, okay, if you graph 33, the graph will look like this. Okay, and I'm asking you what's happening at 5 from the positive side. So since this is going down, you'd put -infinity. In 35, I'm saying what happens when I approach 3 from the right? Well, it's going up, so you'd put infinity. Okay, so try those out. And then page 199, this is the limits as x approaches infinity, and I need you to treat these differently. All right, so remember, if I said to you, hey, I want you to find limits as approaching, and x is approaching a real number, you try to sub it in. If you get a number, that's your answer. If not, if you get a number over 0, you can say does not exist. If you get a number or 0 over 0, you try to simplify it. If for some reason you can't do it algebraically, you try to find the graph of it. And if that doesn't work, using a table will always work. Now, in this case, these things are always going to be different. If I'm ever finding the limit as x approaches infinity or -infinity, I have to treat them differently. Here's where we look at what the tails are doing. So what we do is, if it's a rational expression, we compare degrees. So for 15, the limit as I approach infinity, well, if the degree on bottom is bigger, it's 0. If the degrees are the same, it's the ratio of the lead coefficients, which is 1 to 1, so it's 1. And then if the degree on top is bigger, what you do is you simplify these two. X squared over x is x. Okay, so I kind of showed you right here. So we got 0, 1. X squared over x is x. So that's what my line is. So as I approach infinity, I'm going upwards. So that's how I get infinity for part C. So for part B, degree on bottom is bigger, so it's 0. Degrees are the same, so it's the ratio of the lead coefficient. So it's negative 2 over 3. And then here, this simplifies to be negative 2/3 x. So if we come over here, I have negative 2/3 x. And I'm wanting to know, okay, as I approach infinity, well, if that's what it looks like, I'm going down, so I put negative infinity. Okay, so do the best you can on these. And if you have questions, let me know. Thank you.